Any questions on that? So one more time, your answer, your calculator should spit out 4, 3, 2, 1. All right, any questions from the homework? I guess we'll start with that right off the bat.
Is it going to be like tonight's homework?
It will not be like tonight's homework because we're going to multiply tonight's homework. Concept-wise, yes. Involvement-wise, it's a little more involved to do multiplication.
What about time-wise?
Time-wise, it's going to be a little more time.
Oh, okay.
Okay, if there's no questions about last night's homework, then let's go into today's. Matrix multiplication. We're going to be multiplying multiple matrices together. Yesterday, we did addition and subtraction. In order to add and subtract matrices, they had to be the exact same size. They had to be the exact same size. We do have constraints on whether we can multiply, but this time it's slightly different. They can be the same size, but the only thing they have to be is the number of columns of the first matrix must equal the number of rows in the second matrix. That is the only requirement in order to multiply. The product matrix will have the dimensions equal to the number of rows of the first matrix and the number of columns in the second matrix. Do you want to think about that the entire time when you're doing multiplying? No, probably not. So let's look at an easier way to do it that's already set up for you. Look at this first one. This is a 2 by 2 matrix being multiplied by a 2 by 1 matrix. In order to multiply, the columns of the first matrix must equal the rows of our second matrix. The easy way to check this is to write the numbers down below, just like I did here, and just check these two. These must be equal in order to multiply. As long as those two numbers are equal, and you did this correct, because it's rows times columns, rows times columns. As long as you wrote it correctly, and these two numbers are equal, you now can multiply. And what I also want you to notice, for you to be able to check your answers at the end, your remaining numbers, this 2 goes with that 2, and that 1 goes with that 1. So just writing this out, the middle numbers tell me whether I can multiply them, and the outside numbers tell us the size of the matrix of our answer. This is a good thing to do because then you can check to make sure you did all your multiplications and stuff correct, that you result in the proper sized matrix. Easiest way to check. But the only way you're going to do it is if you're writing this consistently and you get used to doing that. So we're going to do that on the very first one. We're going to say this 2, 5, 5, 3. There's 2 rows. And there's also 2 columns. So this is a 2 by 2 matrix. Our next one has 2 rows and 1 column. Remember, columns go up and down just like a building column. Like you see columns outside of buildings. They go up. Our rows go sideways. So this is a 2 by 1. So below it I'm going to write 2 by 1. And I'm just going to check to make sure 2 equals 2. That is good. I can multiply these 2 fractions. Not only can I multiply them, I know the resulting matrix is going to be a 2 by 1. Our resulting matrix will be a 2 by 1. All right, now how do we actually do the multiplications? So let's go back here. We're supposed to, the entries in each row are multiplied by the entries in each column. Here's how I still do it, just to keep my numbers straight and not to mix stuff up. I honestly circle the top row. I circle the whole top row every time I do these. Not so much for the 2 by 2, but when I get to bigger ones, just to keep everything straight, I circle the entire row. Then we're going to multiply that by our entire column. So it's row times column. It kind of makes like that L shape. Row by column. And that's going to be our top element. And what we do with that multiplication is, so we do 2 times 1. We do 2 times 1. And then we add 5 times 2. So first element times first element. second element times second element, add those two things together. So then we have 5 times 2. And then we're done with that row. Then we move on to the next row, which is a 5 and a 3. We're going to do the same thing and multiply it by that other column. So in this case, we're going to have 5 times 1 plus 3 times 2. What can help you keep stuff straight and correct? Notice this 1's are both the same in both. The 2's are both the same here as well, just by order. So 1's are on top of 2's, and that's why I put them in parentheses, because they should be the same all the way down if I had more rows to do, and we'll see bigger examples in a second. So let's do the actual addition. So we have 2 plus 7 is going to be 9, and we have 5 plus 6, which is going to be 11. This should be a 2 by 1 matrix, and it is a 2 by 1 matrix. Remember, we knew it was 2 by 1.
Wait, isn't it 12? Not 9. It's 10 plus.
Yeah, it should be 12, not 9.
Were you just testing us?
It was a giant test of my mental math, which was terrible. How did I get 9? That is, what was that? Oh, I did 5. Yeah, that's probably what I did. All right, so it should be 12 and 11, which is a 2 by 1 matrix. All right, the next one I'm doing multiplication, so I'm going to check it. This is a 1 row by 2 columns. The other one is 2 rows by 1 column. These are equal, and my resulting matrix should be a 1 by 1. So we're just going to circle this and multiply that by the elements in that column. So this is going to equal 2 times a negative 3 plus 3 times the 4. Let's get this correct this time. 3 times 4 is 12, right? Minus 6 is going to equal 11. I'm just kidding, it's 6. So maybe Nick was going to yell if I did it again.
Oh, that poor 6, it's all alone.
He's just all by himself. He's a 1 by 1 matrix. 1 is the loneliest number.
What about 0, though? Then it's like nothing.
It's not very lonely. There's nothing there. All right, our next one, we have 2 matrices being multiplied, so I'm going to check to make sure I can even multiply them. So our first one has 2 rows by 1 column. Our next one has a 2 by 2. 2 does not equal 1, so we can't do this. Empty set, wrong sizes, anything you want to put there, you cannot do the multiplication. Don't do the multiplication on the test. That's just so much extra work and so much extra time versus someone that just did this and said, I can't do it. So make sure you know how to check to multiply matrices. All right, our next one is going to be a little more involved. We now have a 2 by 2 times a 2 by 2. Doing my check, I can do 2 equals 2. My resulting matrix is going to also be a 2 by 2 matrix. Now, how this is going to work, we're going to start out the exact same way. I am going to circle my 1 and my 3, and I'm going to multiply it by everything in that column, the 2 and the 6. So let's start this going. Well, let's just do it in red since I copied it in red. So we are going to do 1 times 2 plus 3 times 6. Then we're going to leave a space and we're going to do the next element in this row. And the next element in this row is taking that 1 and the 3 and multiplying it by that 4 and that 8. So we stick with the same row, multiply it by column 1, column 2, by column 3. We just keep going until we end that. So I multiply it by column 1, now I multiply it by column 2. So we are going to do 1 times 4 plus 3 times 8. notice that my beginning numbers 1 and 3 are 1 and 3 here as well. All right, my next numbers I have to work with are that 5 and that 7. We're going to do the same thing. I'm going to take that 5 and the 7 and multiply it by the first column. That's going to give me 5 times. And here is where be smart, don't work hard. I know that 2 is going to remain in this column, right? Because it's 5 times 2, 7 times 6. But if I just use the fact that these 2's and 6's are going to stay the same, I just look at this and go, it has to be 5 times 2 plus 7 times 6. And I can jump to the next element in that row and just go, well, that must be 5 times 4 plus 7 times 8. This shortcut not only speeds up the process of doing this, you will get it correct more often than not as long as your first row is correct. So 1 and 3, 1 and 3, 2, 6, 2, 6, 4, 8, 4, 8, 5, 7, 5, 7. There's a nice pattern there, especially when you get to bigger 3 by 3 matrices. All right, then this is going to fully equal 20, 28, 52, and 76. This is a 2 by 2 matrix. It was supposed to be a 2 by 2 matrix because we said it should be a 2 by 2. We are good. We're on to the next problem. Any questions on those? All right, then we're going to get a little bit bigger. Joss, you want me to hold on for a second? Okay. All right, our next one is going to be 2 different size matrices. And we're going to start off by doing A times B. Do everything in your first box. Some in the other class went to the bottom box. The next box is going to be B times C. So you should have a box that looks like this and one more box below it. Leave everything in this box that we're doing. So don't try to write too big. So A times B is going to look something like this. My A is 1, 3, 5, 7, 8, 2. My B is going to be 2, 4, negative 1, 6, negative 3, 2. I should move that negative over just a little bit. It looks like it's subtracting. Especially when I get to bigger matrices like this, I'm going to double check to make sure I can multiply, because my hope is always like, you can multiply this one. But my hope is if I make you do a giant one, that you can't even multiply it, and it's kind of like one of those trick ones. Well, this is going to be a 3 by 2 matrix. We got 3 rows by 2 columns. This one's going to be 2 columns by 3 rows, so we can actually do the multiplication. And what's a little scarier is our resulting matrix is going to be a 3 by 3, so it's going to be a pretty big matrix. Let's go ahead and do this. So we're going to end up with a 3 by 3, so let's just start forming our 3 by 3. All right, do something like that. We are going to take that 1 and that 3, that row, and multiply it by the first column. So that's going to be 1 times 2 plus that 3 times 6. Then we're going to take that 1 and that 3 and multiply it by that column 4, negative 3, and we're going to stay in that same row. So we are going to do 1 times 4, bless you, plus 3 times that negative 3. And finally, with that same row, I'm going to multiply it by that last column. So we are going to have 1 times negative 1 and 3 times 2. 1 times negative 1 plus 3 times 2. That first row should take the longest out of any of your rows. I put these in parentheses for a reason. They are going to repeat in every single row. So this should be some other numbers times 2 times 6, some other number times 2 times 6. So you just have to look over here and go, well, my next row is 5 and 7. So since we're doing the exact same thing with 5 and 7 to the exact same columns, our next row is just going to have 5s and 7s in place of those 1s and 3s. So we are going to have 5 times 2 plus 7 times 6. We are going to have 5 times 4 plus 7 times -3. And finally, we're going to have 5 times -1 plus 7 times 2. Our final one is just replacing those 5 and 7s with, what do we got? Blue, the 8, and the 2. So this is going to be 8 times 2 plus 2 times 6, 8 times 4 plus 2 times -3, and finally 8 times -1 plus 2 times 2. These problems get really difficult if you don't follow this nice pattern. If you follow this pattern, it goes really easy and you make very few mistakes. If you're consciously every single one of these distributing, you'll get lost. Your hardest one should be the first one, so make sure your first one is correct, and then you know these numbers just kind of fall down, and you just know which numbers you have to replace the 1 and 3 with, the 5 and 7, and the 8 and the 2. This would probably be a good chance to just use your calculator to plug these in instead of just doing some mental math. I came up with 20.
Wait, can you second?
Yeah.
So we can like do it
Well, this is just adding. I'm going to make you do the next one on your own. This is just adding. You're here, right? Yeah, this is just adding. 3 times 6 is 18 plus 2 equals 20. I think you guys can do that, and you're going to do the whole next one all by yourselves anyway. So I got 20, -5, 5, 52, -1, 9er, 28, 26, -4, yeah, 8 times -1 is -8, yeah, that should be -4. And that is, in fact, a 3 by 3 matrix, which is what it was supposed to be. It was supposed to be a 3 by 3 matrix. I'm going to take that 2, 4, and -1 and multiply it by that column, which will give me 2 times 3, 4 times 7, -1 times 2, which I do have in that top right column, which equals 32. Then I skip to that next row. That's 6, -3, and 2. Did the same thing, multiplied it by the first column, so I did 6 times 1, -3 times 5, and 2 times 8. And finally I did it to the last column, and you should have gotten out, like I said, 14, 32, 7, 1. Questions on any of those? Yours didn't come out or not? We're good? All right, then let's move on to the last thing we're going to cover today. Yes?
I have a question on example 3.
Okay.
Are we allowed to use a calculator?
I'm not going to use a calculator on it. I'm not going to use a calculator on this one. So far we just used augmented matrices to represent systems of equations. This is another way to write systems of equations using matrices. This is another way. And we're going to need to know how to write it this way in order to use inverses to solve, which we'll start working on tomorrow and finish up on Monday. But we need to know how to write it in this form. And to know how to write it in this form, you have to make sure that you agree this is true, that this is two systems of equations. So to prove it's two systems of equations, it says find the values of x and y that satisfy this equation. The only method I know how to do it right now is to actually do the multiplication and come up with the two equations that they're looking for. So we are going to say this is a 2 by 2 because I do this check every time. This is a 2 by 1. Yes, I can do it. So I'm just going to do the multiplication of this side. To do that multiplication, once again, you just take your row, 3 and 2, multiply it by your column. So your resulting matrix is going to have 3x plus 2y. Then we move on to the next row, which is 4 and -1, and do the same thing. multiply it by that x and that y element, which will give me 4x plus negative 1 y. I usually would just put negative y equals 1 over negative 6. But just like those first problems you had in your homework last night, if this occupies this space, this must equal 1. If this occupies our bottom row, it must equal 6. So I can rewrite this as normal system of equation. 3x plus 2y equals 1. And 4x, change that to minus y, equals negative 6. Now at this stage, I'll let you use however you want to solve it. I'm just going to use elimination. Just because we haven't done it in a while, I'm going to go ahead and I'm going to use elimination. Just because I can easily see that if I multiply that bottom one by 2, I'm going to create that 0 pair. So rewriting this, I'm going to have 3x plus 2y equals 1. All over 2 times 4 is 8x. Negative y times 2 is negative 2y equals a negative 12. This is my 0 pair. So I'm going to have 11x equals negative 11. X equals negative 1. If x equals negative 1, negative 1 times 4 is a negative 4. So y must equal 2. Yes, y equals 2. I'll let you do that on your own. You just got to plug that negative 1 in for either one of your x's to solve for y. Yes?
So theoretically, couldn't we use a calculator and like
Absolutely.
divide the matrices?
Yeah. To divide the matrices? What do you mean?
Like, couldn't you do like